Hello and welcome to the new episode of Python for chemical engineering calculations. In this episode, I'm going to talk about the Boolean logic. So in addition to the types which we've seen before, such as integer, float, and complex numbers, we can have the types of variables which will represent the logic, true or false. So here's how it works. X equals true. And if I type X, it will say bool, which stands for Boolean. So X equals true. If I type X equals true from a small letter, well, it will obviously give me an error because Python is case sensitive. Okay, so X equals true, Y equals false. So let's see what we can do with it. For example, the Boolean types is used when we're checking various conditions. In programming language, it's quite frequently we need to check whether, let's say, one number is greater than another. Is it true or false? Let's introduce a number, an integer variable, a equals 3, right? And let's see if a is greater than 2. Well, true. It returns a Boolean value of true. A greater or equal than 2. Well, again, this is true. Makes sense. So a less than equal than 2, we get a Boolean false as a result. Another logical operator is not equal. So that is composed of an exclamation mark and an equal sign. So a not equal to 2, well, this is true because a equals 3. We remember that, right? Lastly, there is an operator which is equal to, right? So if this is written as double equal sign and a equals 2, well, this is not true. This is false. We know a equals 3. Well, don't confuse this one with the operator of assignment. So if we assign a equals 2, now a equals 2, and if we do the same operation, well, it will return true now because this is true. But make sure you don't confuse it. By the way, if I do reset and delete all the variables here and do the same thing, it will give me an error because you cannot use your variable in any conditional statement if the variable is not defined. So we need to define the variable first, and then we can check whether it's equal to 2. All right, of course, it's not only for arithmetics. There are other operations where we can use Boolean types, and let's use an example with strings. So I'm going to introduce my string, my str equals hello. Let me print it. And let's see if a letter H is in this string. Well, we know it's true, it's in this string, so that I can say H in my str. And this is true. By the way, I can, well, here I'm returning just a value, but I can assign this value to a variable. So I can say X equals to H in my str. So, and if I print X, it's going to be true. Well, let's use another very similar example. H in my str. Well, this is false because Python is case sensitive. Well, and for a string variable, obviously, capital H is different from a small h. Well, however, if we type the following, H not in my str, we will get true because we used a logical not operator on this condition, on this operation of being in the string. So in addition to a logical not, there are two other logical operators which you will be using if you will be using any programming languages. Well, so in addition to not, there is a logical and logical or. And this is how they work. So let's say I have a variable a, which is true. and I have a variable b, which is true. Well, if a is true and b is true, a and b, well, should be true, right? Makes sense. So now, if I introduce the variable c, which is false, and I say a and c, one of them is false, so, well, if at least one of them is false, then the entire thing is false. So a and c is false. Well, if I use the OR operator, I can say a or b, well, true, a or c, also true, because if at least one of those is true, the result should be true. So let me finally introduce d, which will be false. And if I say d or c, well, that would be false. So false or false, well, for sure false. And d and c is also false. Well, if I say not d and c, well, I'll get true because I'm taking the opposite to this result, opposite to these false. Or I can say a and not c. That would be true because not c is true and a is true.